Work on rationalizing a denominator. So a denominator is considered the bottom of a fraction, right? This is a common practice so that everything on the bottom of a fraction is some type of whole number instead of having things that, this will be some value of 4 dot 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 3 dot 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 times this. So if you were to actually work it all out, you got very odd numbers on the bottom of the fraction. So then it becomes hard if you ever, like the reasoning behind this, if you ever have to combine this with another term, it becomes very difficult to work with these. So we try to rationalize the bottom, the denominators of things. So in order to rationalize the denominator of something, you're essentially multiplying both the top of the fraction and the bottom of the fraction by the same number. And that's how we find like lowest common denominators or common denominators. But in this case, we're going to multiply by the denominator of the fraction itself. So we're going to be multiplying by, think of it like it's a set of brackets here. So we have root 17 plus 6 root 3. Okay, and whatever you do to the bottom, you also have to do to the top of the fraction too. Okay, and the reason we do this is because this is going to make sure that everything on the bottom, there'll be no more radical values as we go through it. Okay, but I'm going to split this up. Well, not quite actually. I can kind of put it together. This can all be written as one fraction right now, and then we'll kind of split it up to work on one piece at a time. The top part's going to be 5 times this bracket of root 17 plus 6 root 3. And then the bottom is going to be a type of FOIL, okay? Just because we have binomials. So a common way to distribute binomials is known as FOIL, right? So let's just look at the bottom of this. I'm going to work this out on the bottom, and then we'll put it back into the fraction. Just because of space, we don't have that much space to work on the sides here. So we'll do it in red here. We have root 17 plus 6 root 3 times root 17 plus 6 root 3. So we do the first terms. Root 17 times root 17 is actually just going to be the number 17. So that works out really nicely. Oh, really? And that's the whole reason for this. Think of it like the idea of, and if you ever get confused on that, because those roots are hard to find, we try to think of simple examples. Root 9. Well, I know what root 9 is. So root 9 times root 9 is the equivalent of saying 3 times 3, which is equal to 9. So in other words, we can just keep the number under the denominator. So root 17 by root 17 is that value. Then we have, sorry. And there's one other thing I needed to do. I made a mistake here. Okay, I just caught it as we're going through. When you rationalize, it's not exact. The values of the terms are the same, but we actually have to make sure that the operation in between is the opposite of the operation before. Okay, so here is a plus. We actually have to have a negative operation. Okay, that's very important because that builds something for us that gets rid of some of the radicals. So there's a negative, and we'll talk about how this works here in a second here. So this needs to be a negative. Okay, good. I'm glad I fixed that before we got too far into this. The next thing we do is root 17 times 6 times negative 6 root 3. None of those can really be combined to make anything simpler, so I'm just going to write it as negative 6 root 3 root 17. Okay, I'm writing the 3, it's 6 times root 3 times root 17. There's nothing really that makes this simpler, so just write it that way. Yeah. The next term, we do the inside terms. Okay, so same idea as root 17 times these values.
And they cancel out?
Yeah, because it's going to be positive 6. So positive 6 root 3 root 17. And that's why those operations have to be the opposite, so that these radicals end up disappearing in the end. And then finally, the last one is positive 6 root 3 times negative 6 root 3. Well, positive 6 times negative 6 will give us a negative 36. And then root 3 times root 3 is 9. Just technically just 3. Yes, yeah, technically just 3. So we're going to have to do a little multiplication at the end. So now we're left with 17. These two, because of the positive and negative, disappear. They create a 0. And 3 times 36 is going to give us 108, I think. So negative 108. And then we're going to subtract the 2. 17. 91? 91. Okay. So 91. So let's go back up. We're not quite done. Our fraction still says 5. And remember, this actually has to be a negative 2. Did I fix that up there? Yes, I did. Good. That needs to be a negative 2. So 5 root 17 subtract 6 root 3 all over our new denominator. and our new denominator is 91. This can technically be simplified a little farther. We can distribute the 5 in. It's not going to do anything to the first term, but it will change the second term a little. We're still going to have 5 root 17. But here we can do 5 times 6, so we get negative 30.
So you don't have to multiply by the anything under the square root?
Well, no.
It goes in front.
Yeah, it just drops in front, right? You just do one pair.
Oh, yeah, because it would be like multiplying by 1.
Yeah, exactly.
Yeah, okay.
And then over 91. So this would be a rationalized version of this. So we have a whole number on the bottom, and we have some radicals on top, but this is supposedly much easier for us to work with.